Material balances is the first step for chemical engineering. And chemical engineering is the study of chemical processes or processes. A process is a series of steps that you are going to follow in order to convert something or to do something. And each process is built up with what we call the unit operations. The unit operations are the steps of any given process. And these unit operations are fundamental to studying chemical engineering. You are going to be modeling unit operations. You are going to be analyzing unit operations to see the conditions of operation, right, of the process. The first unit operation that we're going to state is a reactor, and reactors are mainly where the reaction takes place. And it can be seen as a tank, or it can be seen as a pipe. I mean, there are many kinds of reactors that you are going to be seeing, but mainly speaking is the place or the vessel where the reaction will take place. Another important unit operation is the heat exchangers, and this could be condensers, evaporators, boilers, coolers, anything that will exchange the heat between two fluids. And usually you can see them in the diagrams as these balls or spheres with these lines that is like pipes in order for the liquid to pass. You can also have momentum operations or for fluid transport, and these are mainly pumps, compressors. There's a big difference between a pump and a compressor. A pump is for a liquid and a compressor is for a gas. Or you can have storage tanks, vessels. You can see these symbols in the diagram. And the last type of operations are the mass operations. This is in order to separate mass, and it could be a filter, a separator. You can also mix them, so a mixer or a distillation column. You can have many more, and all of these operations, you will be studying them during the whole chemical engineering courses. So most likely you are going to be doing some dimension or seeing the dimensions of these unit operations. You can classify the processes in, well, there are many classifications, but the first one that we're going to study is, you can classify the process in batch process. And the batch process is the process where a vessel, you add the reactants, then everything will start to happen until the system comes to equilibrium, and then you remove it. And then you have what you call the continuous process, and the inputs and outputs are flowing continuously through the duration of this process, right? So you also have what we call a semi-batch. The semi-batch process is going to be the process that is not batch or not continuous, but a mixture of these two. These are the three processes that you can see when working with chemical engineers: a batch process, a continuous process, and a semi-batch. And we can also say that there are two types of system, which are the closed system and the open system. And a closed system is a system where the mass is going to be not going out, nor going in. You can exchange energy, but what you cannot do is to extract or to input some more mass. And usually the batch processes are closed. And the open system is a system where you can exchange the mass. So you are exchanging also energy, and you're introducing more mass into the system or extracting more some mass into the system. So this is usually the continuous process is an open system. And the processes will have also types of state. So we have what we call the steady state. And the steady state is when the variables in the process, temperature, pressure, volume, flow, are not changing with time, right? Uh, uh, if they change in time, we call this the unsteady, or we can also say it's the transient state. Usually batch and semi-batch processes are on the steady state, whereas the continuous process, they could be steady state or transient. Usually steady state in the real life is not going to happen, but we're going to be focusing our first study in steady state. On steady state, in order to study this, we need differential equations. And in order to have a picture of the process, we use diagrams. We're going to be studying two types of diagrams in this course. The block diagrams, which is very simple diagram that is showing what the process is, and you are going to use it to show the flows, the unit operations, and probably some extra data. And you will recognize them because you have blocks. The blocks are the unit operations, and you have the flows that go inside or outside this unit operation. So probably you have seen this. This could be a mixer, right? We have one process where there are two inputs and then they mix or it mix, and you have an output, a solution. And we also have what we are calling a flow diagram. This is more complex diagram. Flow diagram is very used also in chemical engineering. So the flow diagram is where you have the general information, and here you will have some figures that are, each one is a kind of process. So let's say that you have a mixer, right? Probably you can say this is a tank, and you have the mixer, right? And you also are going to state that there are some inputs and there will be an output, right? This diagram is more sophisticated than the block diagram. Usually when attacking a problem very fast, you use the block diagram, but if you want to be more formal with your chemical engineering processes, then you use the flow diagram.